session. We have a technical session on overview of Indian tooling industry by Mr. Ashutosh Sinha, Principal Business Performance Improvement, Nomura Research Institute, Consulting and Solutions. Please welcome Mr. Sinha right here for his session. Let's put our hands together. Come on, everybody.
Sets up the thing. Thank you for the happy table game. I think makes a little bit of my life easier. The post-lunch session that I was requested by Tagma. So first of all, let me start by thanking Tagma for allowing me this opportunity to speak to you. I think this has been a very long association with Tagma and the tooling industry, and I feel elated to see this session after possibly 3 years, the physical session that we are doing. And I can feel the enthusiasm in the team, in the room. So for today, the presentation, the topic that I've chosen is, that we've chosen is a need for collaboration in the Indian tooling ecosystem and how that can improve localization. I think this, during the first session also, the first half of the day also, this must have been discussed multiple times. So let me just stress upon a few facts and figures and also some of the suggestions that we've thanks to working with the tooling industry closely for last 3-4 years, years that we've been able to gather. Yeah. So what we intend to cover in today's discussion are 5 points. First is an overview of the Indian tooling industry. Then we talk about a little bit understanding that we've developed from the buyers, what the buyers want, what do the OEMs want, what are the challenges that the OEMs and tier ones are facing when they are buying or procuring tools especially. And hence the need for localizing the tools in India, localizing when we say localizing the manufacturing of tools. What we can learn from the global industry, some benchmarks that we will discuss. And of course, what could be the steps to address the challenges of the tooling ecosystem in India. So let me start by a glimpse of the Indian tooling industry. So I think this is something that will not be very surprising to all of you. What we see is the global tooling hubs are concentrated in a few geographical areas around the world, primarily led by China, US, and Japan, which constitute significant portion of the manufacturing as well as automotive industry, and similarly in line with, and the trend follows for the tooling industry as well, which if we see reflects in this graph. I think this is something that we've been talking about for some time. The tooling production ranking that we see, so China, US, and Japan are the top 3, and similarly the rankings for vehicle production is also in line with that. So India is the only exception where the global auto manufacturing hubs, I mean, they have a robust tooling industry as well, which is domestic industry, with an exception that India is currently. So India, we see the production ranking is 12th globally. That's around 2.5% of the total tooling market that India has, while it is 4th in vehicle production ranking. So definitely establishes the need for development of a robust tooling ecosystem in the country. Now, there are some inherent demand drivers or inherent advantages that India has, or potential opportunities that India brings for the development of the tooling ecosystem. So one of them is the shrinking product life cycle, and especially talking about the automotive, and of course this reflects in multiple other segments as well. Primarily, if we see the consumer's behavior is changing. They are looking to change their products that they consume or that they use, especially automotive. So for an instance, the case in point being the average lifetime of a vehicle, we see that is something that is shrinking. So I mean, if you see in the graph below, so if you see in the graph below, okay, no worries. So if you see in the graph below, as we see, I think the Maruti 800 sales showed a decline in close to, I mean, only after showed decline after 2 years of its launch in 1984. Sorry, not 20 years, that's a typo. While the Hyundai i10 sales denote a shorter product life cycle. So primarily what we see, no, I'm fine with that. Yeah, thank you. So if we see the trend in, I mean, in general, the product life cycle is something that people are looking to change more often, the products, and that is something that is reflecting in the overall production as well as that will have a bearing in the automotive tooling industry as well. The second element is that India is becoming a hub for frugal engineering, and that is something, again, as we see some aspects from the automotive. So 1/3 share in the total worldwide small car production is coming from India. There are investments in the segments, and they are de-risked by big domestic market for small cars. So India is, as we saw in the earlier slides, is the fourth largest automotive market in terms of production. And we, of course, have a large vendor base for small car components. So India, as we see, is a hub for frugal engineering, and that is something that we've started seeing in terms of more involvement of the Indian counterparts of global OEMs in the overall product development as well as manufacturing, and that is something that we've talked about in the OEM, in the example of Vitara Brezza, how that was very well worked out with a deep collaboration between Suzuki and MSIL. So there's a growing trust from the headquarters in the Indian entities as well, and that is where we see the trend for localization becoming more commonplace in automotive. So this was an overview of the tooling industry. I'll not spend much time because this is something that is known to most of you, but let's talk about what the buyers, when they procure the tools from the tool makers, what do they look at? So as we see, and this is something that we've spoken to close to 150 tool rooms during our course of engagement while we were working for Tagma a couple of years back. So this is something that we understood and we want to discuss. So first is, most important is the cost, quality, and availability. That's the basic thing that most of the OEMs and Tier 1 will look for from a tool maker. That's something that you have to, that's hygiene that you have to take care of. But the other three elements are something that is a requirement or an expectation from an OEM or a Tier 1, which they expect from their tooling supplier. And that could potentially translate into imperatives for the tooling industry as such. So if we see a design capability, so tool designing capability and ability to incorporate the small changes in designs, something that's what we call as agility in terms of making engineering changes, that is something that the OEMs and Tier 1s are looking for. The response time to design changes need to be low, and work experience of tool designers is a key factor. So engineering skills is something that, again, that the OEMs and Tier 1s are looking for. The overall tooling, as we all know, it has a very strong element of program management. It's an entire engineering process, and that will require very strong program management skills to meet the cost, to keep the cost under control, as well as the timelines of the overall project under control. And that is where we see the tool room's financial capability and working capital becomes an important parameter when they are dealing with the OEMs as well as Tier 1s, because the OEMs and Tier 1s want to ensure that we do not run, I mean, any of the projects that they are outsourcing to the tool rooms do not run out of steam. And then, of course, use of demand planning tools and program management capability of tooling suppliers is something that an expectation that we've gathered and captured from the OEMs and Tier 1s. And of course, in terms of tool room infrastructure, sufficiency of tooling equipments and machines and use of quality instruments and sufficient tool assembly space are some of the expectations from the customers. Now let's look at some of the trends of the imports. Still, we see out of the total close to around 18,000 crores of the tooling market in India, around 5,000 to 6,000 crores is still imported. And out of that, automotive forms close to around 67 to 70% of the total imports that comes into India of the tool. And this is a breakup of sheet metal dies, injection molds, and die casting tools. As we can see, there is an increasing trend that we see in the imports. So definitely, there are expectations that this indicates that there are some inherent issues or challenges which the customers are facing with the Indian tool rooms, which needs to be addressed to promote the localization and to sustain localized manufacturing. Now, what are those reasons that are making the customers or the OEMs and the Tier 1s depend on imports? The first that we understand is critical parts tooling. So what we understand is that there is a lack of adherence of ITRs to stringent quality requirements. for critical big parts and ultra-high tensile parts, and hence they are imported directly by the OEMs. For example, the body side panels and fenders, critical tools like LED lights and backlights, these are mostly imported as we understand. Similarly, high aesthetic parts are not something that are trusted with ITRs is as a trend that we see. Of course, we will always have exceptions, but as a trend that we see that aesthetic parts like bumper tools, like IP, like dashboard, fascia parts, they require specific texturing and smooth finishing, and hence they are the ones where they are not where the ITRs are not possibly trusted with orders. In terms of skill, so we understand that there are major skill gaps of ITR manpower, especially in the computer-aided engineering aspect. That is what the OEMs and tier ones feel about it. And of course, low ability to respond to design change requests. So that's something that we had also captured earlier. And the last is infrastructure and high delivery time. So they as we've already discussed. So these are some of the key reasons why the OEMs and tier ones are resorting to import still. And not as much depending on the ITRs currently. This is on the timeline part, again, something as we see the key takeaway for us from here is that from a concept to final launch, an ITR typically takes around 5 to 6 months, while a global tool room, the GTR, is approximately 2.5 to 3 months. What are the differences that are there across the overall value chain? What we can just bring about is, in terms of machining equipment, the smaller ITRs are using 3-axis machines or 5-axis machines, while the GTRs are using 5-axis machines with 4,000 RPMs for die and mold roughing and high surface finish and form accuracy. In the overall ecosystem, I think it's a common knowledge across all the ecosystem. Most of the work the entire work from end to end, from designing to manufacturing by Indian tool rooms is done in-house, while there is a very robust and strong outsourcing ecosystem developed for the tool rooms globally, especially in Taiwan and Japan. We'll talk about that in more detail in subsequent slides. So that is something that helps these GTRs in reducing the time to market. And that is something that they have an inherent advantage. Process iterations, so due to lower design capabilities, T0 to post-trial die correction takes a long time for ITRs, while that is something that is not a problem faced with GTRs. And time to market is high due to import dependency of tool, steel, and bought-out parts. So we still have a significant dependence on some of the input material that is there. For instance, tool, steel, and there is a lot of bought-out parts for ITRs. And hence that increases our dependency and does impact our overall project execution timeline as well. This is a broad assessment. We see the technological leadership, the high-skilled workforce, and the time to market. These are the 3 pain points that Indian tool rooms are facing vis-a-vis the global tool rooms, and needs to be addressed with immediate effect. Now, this all, of course, reiterates the point that there is a need to increase the localization of tooling in India, especially now. Why is basically because of 3 key reasons. One is tool room. We've achieved significant level of localization in the automotive value chain. So right from the OEMs localizing their tier 1 supply chains, now the next front, and of course a large part of the tier 2 supply chain. Finally, this time is now to localize the mother industry, which is the tool rooms. And that is where there will be a significant push, and we expect, it could be a mutual relationship between the customers and the tool rooms. If we provide the right quality and the right product, then of course there will be a pull from the OEMs as well as tier 1s to localize the tooling ecosystem for them as well. So this is, and of course with the overall policy push towards localization, towards self-reliance, towards Make in India, this is the right time to drive this kind of initiative. Similarly, there are certain geopolitical issues as well as certain unforeseen situations like the COVID-19 pandemic that we saw, which necessitated and reiterated the need for localizing supply chains. So even if there are supply chain disruptions which are happening, a lot of import dependency had hurt a lot of companies, and that is where I think the need to have a localized supply chain, especially from a tooling point of view, is extremely critical. And third is pricing issues and pricing pressure. With the shortening of product life cycle as we had seen, and the customer in the end-use industry is becoming more demanding, and with a lot of competition in there, there will be, the OEMs and the tier ones will be facing extreme pricing pressures, which then will drive them to drive localization in the tooling space. So there will be a push from the tier ones and OEMs as we feel, but of course the tooling industry has to respond in a positive way to make this localization thing actually happen on ground. So a couple of things that we can learn from some of the global best. So we've presented two cases here. One is from Taiwan and the other one is from Japan. And if we see why Taiwan has such a strong or a robust tooling ecosystem, so there are four reasons that we see. One is, of course, the tooling ecosystem. So they are closely knit industrial clusters and sub-tiered production process, as I think a lot of people here would appreciate. In the Indian tool rooms, there's a trend to do most of the things in-house, while the larger tool makers form partnerships with small tool makers with niche capabilities. So which, of course, is something that we talk about in more detail towards the later part when we talk about suggestions. So this is something that is an advantage that these larger tool rooms get. And certain components of tooling are subcontracted to the niche tool makers, which helps them shorten the lead time from the overall concept to launch. Institutional support, of course, that's something that has been there. Provision of various tax incentives and extending preferential loans to the TMD industry has been there in Taiwan. TMD, when we say it's tool and machine dies. And then investment in skill creation and technology upgradation. For instance, the opening of MRDC R&D Center in 1963 to encourage investment in molds and dies sectors. Third element is technology and knowledge transfer. So transfer of technology and technical skills happened from Japan. That is something that was done well by Taiwan. So guidance by Japanese engineers in Taiwan and working with Japanese clients. And they also formed a lot of JVs with the Japanese tool rooms. So that's the way they acquired the necessary technology and knowledge from tool rooms in Japan. And of course, unique cluster of machine tools industry, for instance, availability of low-cost machinery and proximity of the overall tooling ecosystem to machine tool suppliers, leading to easy repair and maintenance, because of course the machines that you will be using for the engineering will require maintenance and repair, which is where I think this part becomes important in shortening the lead time and also manufacturing at a low cost. So just an example of how it has been. So if we see the overall tooling cluster, Shulin City, which has an industrial park dedicated to metal processing industry, and the cluster of tool rooms, design centers, machining centers are present in and around the Shulin district. And how it is spread is one half of the tooling producers are located in the industry-intensive north region, and which is the TDM firms surrounding Taipei are not involved in the tool production, are involved in the tool production for electronics industry. Central Taiwan serves hand tools and machinery industries, and southern Taiwan are serving the automotive industry. So they have geographically also clustered themselves serving to different end-use industries, and hence they are able to cater to the multiple end-use industries as well. So co-location advantage in Taiwan, which helps them in large-scale subcontracting. So equipment and manpower sharing, that is something that they do very aggressively, is what we've seen. So tooling firms support each other by sharing equipments, manpower, and molding costs, thereby offering faster tool delivery. So there is competition, but there is a lot of cooperation among the tool rooms as well. Tiered production, various small family-owned tool producers take up subcontracting for specialized processes or functions, and export orientation is something that is helping the overall Taiwan tooling ecosystem develop. Now let's talk about Japan, which is of course one of the most developed tooling ecosystem that we've seen. So what are the key characteristics of the Japanese tooling industry? So they are driven by the local automotive industry, of course, as we saw in the first few slides. That is one of the things which is putting the demand for the tooling industry. So close to 60% of the tools produced find end usage in the automotive industry. So there is a significant amount of capacity utilization that is guaranteed by the automotive industry. High level of automation and small and medium tooling enterprises. So more than 70% of the enterprises have less than 10 employees. So we see that there has been a significant amount of investment in automation, and that is where they are able to, the small scale industries or with very small setups, they are able to achieve high engineering excellence as well as manufacturing. Japan is the third largest exporter of injection molds after China and Germany, and there is a high degree of innovation and complexity in tools due to presence of highly qualified employees and accumulated work experience over the over the last so many years. And the technological and process expertise is at the highest international level, of course, Japanese, as we know. Now, if we see the journey of Japan and the Japan's tooling ecosystem, how they have developed in the last, from the 1930s. So the first phase was when there was a strong domestic demand due to rise of automotive industry. That is where the initial 1930s till 1950s is something that is where the tooling ecosystem was. Somewhere, I think probably we in India, we would lie somewhere in the mix of between phase 2 and phase 3, where phase 2 was machine industry promotion law aimed at, so there were government incentives and laws which were then, so policy intervention, which then started to, because there was an automotive industry which created a lot of demand for the tooling industry. There was again a push from the policy side. And the third stage was again in introduction of high performance machine tools and mechanization. That's the third step that Japan took. And then the fourth was digital technology and process expertise, which is where from the 1970s to 1990s. So that's how Japan grew, Japan's tooling ecosystem grew over the last, from 1930s to the 1990s. Now, all this we understood. Now, what could be done? Of course, there is that we understand, and I think most of the people in this room will agree that there is a need to localize tooling. But what could be done to do this, to ensure that the tooling ecosystem is robust and developed in India? So we suggest, I mean, that's again based on our interactions with the tool rooms over the last 3-4 years. We suggest 3 key steps that could be taken. The first is development of a tooling outsourcing ecosystem. That's easier said than done because, of course, there will be certain challenges, and we can talk about those in subsequent slides. Second element, I think that's also something which was touched upon in the earlier sessions, was formation of tooling clusters. And the third is partnership with global tool rooms to access technology and knowledge. So I'll not go upon these. I think this is something that that has been and that is known to all. But I think basically the ecosystem development would mean focus on skill, access to finance, which will be also a contingent on help from OEMs as well as the government, access to infrastructure, technology transfer, research and development, and export promotion. But what I'll do is I'll spend some time on how a collaboration or a consortium formation could be achieved. So the first step to that is to identify the synergies that the tool rooms have, where the competition could be set aside and the cooperation element could be brought in. So for instance, there could be demand synergies between two or three or a cluster of tool rooms that are operating. So the tool rooms that are working on complementary products can possibly come together and collaborate. For instance, Class B and Class C sheet metal tools. Similarly, the location synergies could also be explored. For instance, the thing that we saw in Taiwan, similar things like geographical synergies in tool rooms operating in the northern part of India or the south or western part of India can form geographical clusters and then collaborate. Third is around similar customer segments. Again, that is something that we saw in Taiwan happening, that there's geographical clusters which are serving to end-use industries. Then there could be a balance of power. For instance, tool rooms of similar size and operations can possibly come together and collaborate so that there is not fear of one engulfing the other. That could also be a synergy that could be explored. The fifth is logistics synergies, which is ability to co-transport or store, which can help the tool rooms reduce and work out the cost. And the last is process synergies. So similar processes like CAD, CAE, project management, etc., could also be explored for synergies. And this is just a broad outline of how, because we are not forming, we are forming a very loose alliance here. We are opting and talking to collaborate. So this needs to be run by a very strong governance framework, which is where I think the model is something that we've detailed out. I'll just spend 1 or 2 minutes here explaining that. So there are multiple tool rooms, and tier 1 to tier 4, these are the tool rooms. This is just an illustration that we've. So how can they collaborate? So in terms of resources, for instance, they can commit resources for cross-organizational project teams for joint CapEx decisions. business case, market intelligence, and demand aggregation. So how, I mean, if you have to collect market intelligence from the end use industries or for the end use industries to actually decide on capex and everything, that could possibly be done by a joint or a collaboration by the tool rooms. Similarly, capabilities, so member organizations can share best practices and knowledge through various forums, joint publications. And of course, there could be funds where member organizations can contribute to common funds and capex and business development activities. For instance, co-investing in a heat treatment facility, which could possibly be a non-competing one, but if that ecosystem or that facility is developed, a lot of the problems, some of the problems for the existing tool rooms could be solved. So elements of government framework will have to be decided and thought of very in more depth, but what they will be driven by is 6 principles. So one is how the reward sharing is happening between the tool rooms. What are the risks, how the risk and conflict management is happening. How the performance monitoring, it's not that someone is more committed and the other tool room is probably, so no one should be free riding. So definitely how is the performance and monitoring reporting happening. How is the investment for shared pools and assets there? What kind of investments are coming from what kind of, is it contingent on size? Is it contingent on any other factors? And of resource sharing mechanism, who will commit how many resources for joint activities and joint projects? And of course, the change management overall process. So these are the things which have to be kept in mind to form a consortium of this sort. And of course, collaboration with global tool rooms to access knowledge and technology is another option. Not spending much time, but I think what Indian tool rooms get is access to latest tooling technologies, access to highly skilled workforce and world-class R&D facilities. What could be a potential pitch to the global players is that you get a foothold into world's 4th largest automotive market. So why don't you come and collaborate with us? Access to existing clientele, which I think the Indian tool rooms have. Some of these have a very strong client base in terms of Indian OEMs as well. And of course, a very strong know-how of the market scenario, product demand, and customer requirements. So with this, I end my presentation. I think I have been given warnings that I have probably ran out of time. But thank you all for a patient hearing. And of course, I look forward to interact and answer any of the questions that might have cropped up in your mind.
Thank you so much, Mr. Sinha, for that wonderful presentation. May I please request you to join us center stage? May I please request Mr. Paresh Panchal, Executive Council Member, Tagma India, to please join us on stage to hand over a memento, and thank Mr. Sinha for joining us here for this wonderful session. Ladies and gentlemen, would you please join us in thanking him for sharing those wonderful insights with us? Thank you. Thank you.